Greetings everyone. Today we team Yantrika 07 team ID 57484 is going to present our solution on problem statement 25214. The solution build is RescueSense. RescueSense is a sensor-based triangulation of life form, highly scalable with AI capabilities.
Our solution is a specialized local system designed to detect live victims trapped under debris during natural or man-made disasters. It works in a self-contained environment where IoT sensors, radar modules, and processing software communicate locally with each other without any external mobile app or internet dependency. Our system integrates radar sensing, microdoppler analysis, and AI-based classification algorithm. Currently, we are using support vector machine, that is SVM, for live sign detection and filtering noise patterns. The solution involves a robust and a field engineered architecture designed to perform even in extreme rescue conditions. The parallel radar array design ensures uniform scanning coverage, reducing the need for multiple redundant sensors. The shared communication module allows synchronized operation between radar, thermal, and sonic sensors while maintaining a real-time coordination with local rescue teams. An integrated air ventilation and microcooling system prevents the radar overheating during prolonged rescue missions. Also, the hardware and the sensor placement is optimized to balance cost, durability, and maximum detection efficiency. The radar sensor is positioned at a balanced scanning height for optimal penetration through debris. The microdoppler sensor is placed adjacent to the radar for the movement amplification and accuracy improvement. Ultrasonic modules measure short-range distance to adjust radar frequency dynamically. Thermal sensor confirm live presence by cross-verifying heat signatures. Additionally, a high-frequency noise emitter helps deter unwanted animal interference during rescue operations. The entire system operates through a locally installed software environment that directly communicates with all connected sensors and modules. The local dashboard displays detailed information like radar signal strength, detected heartbeat pattern, motion waveform, victim confidence score, and environmental temperature. It allows rescue operators to monitor field conditions, manage multiple detection mode, and activate drones or robots for real-time scanning support. A web-based local interface is provided for the coordination between the rescue teams, enabling shared visualization and mapping of detected life signs. This interface allows authorized personnel to review individual detection, events, local coordinates, and victim confidence score. Alerts can be triggered automatically in case of confirmed live detection or abnormal vibration patterns. The system's database is specialized for rescue and detection analytics. It stores real-time radar signatures, microdoppler waveforms, and an AI-verified classification for different types of movements such as heartbeat, respiration, or limb tremor. The solution helps detect the location of a person in the following sequence of steps. First, it maps the position of the human by calculating the elevation and distance from a ground unit. The unit is a single button operable to click and scan the area. The drone unit triangulates the position of the human and also calculates the best possible excavation path. Once the rough coordinates are deciphered, the ML-AI model refines the position by removing noise and smoothing the edges. And based on the output from the drone, ground unit, and the AI, a detailed map is generated for the disaster scenario. This provides the best usual reference for the rescue operation. The rescue team is equipped with a thermal sensor for close encounters. This is the best position for the sensor since thermal sensors cannot work through walls. The rescue team is equipped with a safety gear and a first aid for swift rescue operations. In conclusion, our radar-based live detection system represents a step towards smart, independent, and AI-integrated rescue technology. It ensures that every second counts, helping save lives faster, safer, and more efficiently during disaster operations. Thank you.